Hello, dear grade 7 students again. So today's lesson we are going to talk about 3.5, which is graphing proportional relationships. The learning intention of today's lesson is to understand how to identify and interpret proportional relationships using graphs. The main goal is number one, we are going to identify or more likely recall what's the constant of proportionality. And then we are going to identify how to find it from a graph. Number two, we are going to use a graph to recognize proportionality. And number three, we are going to interpret a point on a graph of a proportional relationship. Number four, I can use the graph of a proportional relationship to solve problems. So the main vocab words of today's class is constant of proportionality and a proportional relationship. So let's move on. Now, the key concept of today's class, of today's lesson, is to be able to identify how how a graph of a proportional relationship looks like. So, the graph of a proportional relationship is basically, this is the main thing that you guys should know. It's a straight line and it passes through the origin. So, for a proportional relationship to be called one, it must have these two conditions, okay? So it must have these two conditions, which is number one, it should be a straight line like this one, and it should start from the origin, from 0, 0, okay? So these are the two conditions to call a graph, any graph that it represents a proportional relationship. So let's look at this one, for example. Here, as you can see, they're telling you if we want to find the constant of proportionality, using this graph, we can easily find it. We know that k is equal to y divided by x. Let's take the value of x to be 1. So when x is 1, the value of y will be 5. Okay, if you're not sure, if we want to make sure that k is actually equal to 5, let's take another two pieces of data. So we're going to try for x equal 2. So when x is 2, the value of y will be equal to 10. And we all know that 10 divided by 2, that will be 5. It's the same as 5 over 1. So since we have, as you can see, since we have each time, if you're not also sure, you can take a third piece of data. So we're going to take 3. When x is 3, the value of y will be 15, and that's also equal to 5 over 1. So as you can see, we have here a constant ratio each time we divide y by x. So the constant of proportionality in this question is 5. And that means this is a proportional relationship. Again, what makes a proportional, the graph of a proportional relationship should look like what? It should have two conditions. Number one, it should be a straight line and it should pass through the origin, okay? So how can you interpret a graph in real life? Here you can see 0 tickets. The x-axis here represents the number of tickets and the y-axis represents the cost. So what does 0, 0 mean in this real life application? That means you bought 0 tickets and you paid $0. 0 tickets cost you $0. 1 ticket cost you $5, and so on. Okay, so let's move on to another real life application about interpreting the graph of a proportional relationship. So the graph shows a proportional relationship between the distance and the amount of time Mr. Brown drives. Now, number A, what does each of these points represent in this situation? 0, 0. So always, guys, we start with the x, look at the x-axis, and look at what the y-axis means. Okay, so the x here means time. It represents time. And the y-axis represents the distance. So 0, 0, what does it mean? So in 0 hours, Mr. Brown drove 0 distance, 0 miles. Okay, 0 hours, 0 miles. Let's go to 1 and 55. In 1 hour, Mr. Brown drove 55 miles. Okay, so from where again, you guys are going to get the keywords? From the graph itself. Okay, start with the X, time. What unit he's using for time? Hours. So you should use the word hours. Okay, in 1 hour, he drove 55 what? Miles. You should use these two keywords, hours and miles. Okay, in 2 hours, he drove 110 miles. In 5 hours, he drove 275 miles. So this is what does each one of these ordered pairs represents. This is how you guys are supposed to write it. 1 hour, Mr. Brown drove 55 miles. 2 hours, Mr. Brown drove 110 miles, and so on. Now, number 2, they're asking you for B to find the constant of proportionality. Again, how you find the constant of proportionality? It's the same thing as what we did in 3.4. You will just write the equation y equal, no, not the equation, guys. They're asking you for a constant. That means we're going to have to put k equals y divided by x. So we're going to take any two values for x and y from the graph. So when x is, I will start with 1. Okay, you guys, we're going to take 1. When x is 1, y will be equal to 55. Okay, let's try another value. When x is 2, y will be equal to 110. So we can conclude when you simplify, when you divide 110 divided by 2, you're going to get what? 55. So we can easily conclude that k is equal to 55. That's the value of the constant of proportionality. Okay, you guys? Again, if you are not sure about taking one piece of data, take another one. Okay? Until you get the same answer, you feel confident to write your final answer. Okay, now part C. What equation relates? Okay, so here they're asking you to write the equation of proportionality. We all know the equation of proportionality is y equal kx. So my equation will be y equal, I'm going to substitute the value of k with 55 and keep x the same. That's my equation. Okay, so as you can see, it's the same. It's mainly related to 3.4. We're just getting to know a new idea, which is how to get k and the equation from a graph. That is the new thing that they're adding to you in this lesson, and how to also identify if this graph represents a proportional relationship or not. Now, if we want to check does this graph represent a proportional relationship or not? Yes, it does. Why? Because number 1, it's a straight line and it is passing through the origin, through 0, 0. Okay? So, you guys, it's definitely a straight, it's definitely a proportional relationship. Okay, so this is an important note, you guys. This is really, really, really important. You have to know when a graph is a proportional relationship and when it's not by just looking at it. Okay, so the first one, is it a proportional relationship? We took 2 conditions for a graph to be a proportional relationship to represent one. And number 1, it's that it should be a straight line and it must be passing through the origin. And it has this one and it has this one. So the first graph, it's a proportional relationship. Look at the second one. The second one, it's a straight line. But does it pass it through the origin? No, it doesn't. So we cannot call this a proportional relationship. It's not proportional. It's a straight line, but does not pass it through the origin. And the last one, is it a straight line? No, that's definitely not a straight line. It passes it through the origin, but it's not a straight line. So we cannot say it's not proportional. Not proportional, proportional. Okay, guys, so you really should know what makes a graph a proportional. 2 conditions, straight line, passing through the origin. Please keep them in your minds. Okay, keep them in your mind. You have to memorize them by heart, these 2 conditions. Okay, let's move on now to more real-life application, more book questions. Okay, now here the graph shows the number of boxes a machine packages over time. Now they're asking you number one, is this relationship, sorry. Okay, is this relationship here, this one here, is it a proportional relationship? Let's see. Do we have a straight line? Yeah, we do. Is it passing through the origin? Yeah, it does. So yeah, it is. So you have to write yes, it is a proportional relationship. Now the second part of the question, you guys have to pay attention when you read any question. Sometimes they're not asking you just to find one thing, they're asking you for more than one thing. So they're asking you for 4 minutes. So we're gonna go to our graph. I'm gonna look for the value for when x is 4, my y will be how many boxes? So in 4 minutes, the machine produces 100 boxes in 4 minutes. Okay, this is how you guys should answer your question. Let's move on here. Does this graph represent a proportional relationship? Okay, as you can see, it's a straight line, but does it pass it through the origin? No, it doesn't. So is it a proportional relationship? No. So can you find here the constant of proportionality? Definitely not. You will not have a constant of proportionality because it's not proportional. Okay? So please guys, keep that in your mind. If the relationship is not proportional, you cannot get a constant of proportionality because it's not proportional. So there is no constant. Okay, so let's move on. This one here, what does the 0.00 represent in this situation? As you can see here, we have cups of flour related to the cookies that you guys make. So if the baker here uses 0 cups, what does 00 mean? It means he uses 0 cups of flours, so he got 0 cookies. 0 cups of flours is equal to 0 cookies. That's it. Okay, the 0.118, what does it represent? The same thing. For every cup of flour, he gets 18 cookies. So you should look at what x, this is x and this is y. You should look at what x represents and you should look at what y represents and speak the language of a graph. Okay? So for every 1 cup of flour, you get 18 cookies. In other words, guys, 18 is the constant of proportionality. Okay? It's the unit rate. It's the ratio. Because every 1 cup, you get 18 cookies. So 18, basically, it's our constant of proportionality. Okay. So you should know how to use that using words. I think it's written in your book, written in the answer key. So study how it's written. Okay. And here, what does, why will the graph of every proportional relationship include 0, 0? Of course, they will include. Because when x is 0, y will be equal to 0. So y is equal to kx. That means y is equal to k times 0. So that will be 0. Every proportional relationship, they must start with 0, 0. Okay? Because common sense, guys, when x is 0, the y also should be 0. Because when you substitute the value of x in the equation, you're going to get any number. And whatever k is, if you multiply it with 0, it's going to be 0. Okay. So let's look at this real life application. So here you should tell me which statements about the graph are true. Okay, so let's start with the first one. The 0.110. Okay, do you have a 0.110? Okay, 1 means, always remember, the first coordinate that's the x, the second one is the y. Now look at the x. Do you even have 1? They're telling you 1. Assuming, okay, 1 is here. Does that make it 10? No. 10 is related to what number? You can see that 10 is related to number 14. The value of 10, you get it when x is 14. So there is no such thing. So that's an x. Now the constant of proportionality is 5/7. Let's discover that. So we're going to take the value. How do we find k? it's y divided by x. So we're going to take x as 14. When x is 14, y will be 10. Let's simplify it. I think they both can be divided by 2. So 10 divided by 2, that's 5 over 7. Yeah, it's correct. So this one is an answer. Okay, so how do you find the constant? Take any value of x with its alternate value of y, with its opposite value of y, connected value of y. You know, x with its connected value. And then you divide them. Now, the graph does not show a proportional relationship. It does not show. That's definitely wrong. Look, it's a straight line and it's passing through the origin. So that's an x. The graph is a straight line through the origin. Yeah, it is. It is 100%. Now, the point 28 and 20 means the type of the plant. Okay, this is 28 and that's 20. It means that the plant grows at 20. Yeah, that's at 20 millimeters when it rains at 28 centimeters. Yeah, the units are correct. If they flip the units, if they said 28 millimeters, that will be wrong. But here they put the units correct. So yeah, it's a correct statement about the graph. Okay, guys. So yeah, that's it for this lesson. And the last question, I'm gonna leave it for you. Here they're asking you tell whether it's a proportional relationship or not. This question is similar to this one. Okay, so you can get your answers from here. You have the same two reasons. It should be straight line and it should be passing through the origin. If it's not straight line, then it's not proportional. If one condition is out, then we cannot call this relationship a proportional one. Okay, so that's it, guys, for today's class, and see you when I see you.